Welcome to this video on the line of best fit. By the end of this video, you should be able to use bivariate data to determine the correlation of a real-world scenario. You should also be able to use bivariate data to generate an equation for a line of best fit. And you should be able to use the equation of the line of best fit to make predictions. Okay, so what I'm going to have you do is I have the directions here for putting our correlation into our calculator. If you do not have a graphing calculator, I can show you how to do this on Desmos. Okay, so you can download a graphing calculator emulator onto your phone. There's a great free one for Android called Wabbit Emu, like rabbit, but with a W, Wabbit Emu. And there is one for Apple TI-84 emulator. It is a $5 app, but it will do some of the things for free. I am not sure if it does this for free because I don't have an Apple, so I don't know, all the things that it can and cannot do for free. But this is my phone with the emulator on there, so you can see the idea of how good an emulator can be. So I have the directions right here for the graphing calculator. To find the correlation coefficient, first you're going to press the stat button. And so the stat button is right here, S-T-A-T, stat. You're going to choose edit. So you just hit the enter button, which is equals. Now you should see these lists. Yours may be empty. Mine I've already done something in, so I'm going to show you how to delete this out in case you've got it. I'm going to go arrow up into where the L2, this means list 2, is highlighted. And I'm going to press clear, enter, and it's going to clear the whole list out for me. Then I'm going to go over to where L1 is. That means list 1. Clear, enter, and the whole list is cleared out. So, once we're clear, you're going to put the X values in list 1 and the Y values in list 2. These must be done in the same order. These are a coordinate pair. These are points on a graph. So you cannot split them up. So to put these in, I'll say 1, enter to go down to the next line, 2, enter, 3, enter, 4, enter. Okay. Once I have all my X values in, I'm going to arrow to list 2, and I need to go in the exact same order. 2, enter, 5, enter, 8, enter, 12, enter. Our list should be the same length on both sides. Okay. Then it says press the stat button. Arrow right once, so it says calc at the top. And you're going to choose linreg AX plus B. It's probably number 4. It usually is. So you can just touch the number 4. So we put our data into list 1 and list 2, so that should all be good there. And we just keep hitting enter to go through, and it's going to give me some important information. So remember, when we were talking about correlation, we said the variable they use for correlation is R. So this very last number here, that's your correlation coefficient. So I would like you to use 4 digits. So this is 0.997. That's a 2, but the next number after it is a 5, so I'm going to call it a 3. So my correlation coefficient equals 0.9973. That's a pretty strong correlation coefficient. Remember, it tops out at 1, and this goes almost all the way to 1. Now, what if when you did this calculation, this R information did not show up for you? I'm going to show you what to do. Down here, above 0, it says catalog in blue. So press the blue second button and then 0 to get the catalog. And you should see this list pop up. I'm going to arrow all the way down. I'm just going to keep on going until it says diagnostics on. So it says diagnostics on. I'm going to hit enter, and it says it here on my screen, and then enter one more time, and the word done comes up. Now, once that happens, stat, right 1 to calc, you're going to choose linreg AX plus B, which is number 4. Everything should be in list 1 and list 2. And now you should have it down here. Okay? So let's try the next one. We're just calculating R. Okay? So I'm going to start all the way back over. Your instructions are all the way to your left. You press the Stat button. We're going to edit because we want to put the data in. I don't want this data, so I'm going to highlight the list name, clear, enter. Highlight the list name, clear, and then enter. It clears everything out. Now my X values go into list 1. 10, 15, 20, 25. Then I'm going to go right in the same order. 37, 20, 12, and 1. Once everybody's in, press the Stat button again, arrow over one time to calc, go down to number 4, which is AX plus B. You can just arrow down or just choose number 4. We put our X's in list 1 and our Y's in list 2. So we can just enter, enter, enter. And it's going to give us, all we care about right now is that R value at the end. It's a negative 0.98817, so we're going to make that 1 and 2. So we have R equals negative 0.9882. Okay, so that means the slope of a line that's drawn through the middle of the data is going to be going down. As X increases, Y is decreasing. They have a negative relationship with each other. So now I want to show you how to do this in Desmos in case you don't have a graphing calculator and you're not willing to pay the $5 to put it on your phone or to get a graphing calculator. This is another choice. This Desmos graphing calculator is allowed on the end of course test. So what I have done is on our home page, I put this Desmos picture right there on the front of Canvas. If you click that, it takes you to the Georgia graphing calculator because each state has a slightly different what they allow. So we want to be sure that we're using Georgia. Now, to do this, you're going to come right over here to the plus sign where it says add item, click it, and we want to add a table. And we're going to do the same thing we just did. We're going to take these X values and put them in the X list, and we're going to take these Y values and put them into the Y list. So my X's are 0.5, 1, 2, 2.4, and 3. And then my Y's, I want to go in the exact same order. 4, 4, 1.2, 3, 4. All right. Now, you've not gone anywhere else. Go back to the plus sign and hit f of x expression. Okay? Now listen very closely. I'm going to make a separate video on this, but you will say press the Y and then 1, and it will automatically go Y with a sub 1. Now normally we'd write equals, but this is a little bit special. Click your keypad, okay, and in your ABC there's this tilde sign right down here, and you're going to use that instead of equals. So remember, y equals mx plus b, but our x's, our y's are this y list, and our x's are this x list. So we're going to say m, and then x and 1, and then plus b. All right, all we need from this right now is right here. There's your correlation coefficient right there. So I got R equals negative 0.2428. You should get the same thing if you did it on the calculator. Okay, I'll do a separate video with the calculator and the Desmos as we go on. Okay, so one of the things you have to be able to do is we have been drawing a line through the center of the data. Well, really, that's the line of best fit. So here I have a set of data, and I want to see which one of these lines would approximate the very center of this data the best. So in general, of the points not on the line, about half are above the line and about half are below the line. Okay, and so this line is a prediction line of what if I asked you a question, this would estimate where the answer would be. So let's take a look. So my data, if I envisioned a line going through the middle of it, I'm not going to draw it in right now, I see it's going to have a negative slope. As my x values get bigger, my y values get smaller. Okay, so that means it's negative. That means the slope of the line is negative. So when I look over here, A has a positive slope. It doesn't matter. This can never be the answer because this has a negative slope. Okay, now we're going to get a little fancy with our calculator again. I'm going to put B in the equation. So I'm going to hit y equals, which is right here. Let me move it up a little bit so you can see it. Y equals, this is how you put an equation in. Okay, I'm going to clear out what's there. And we've already got y equals, so I am going to put the negative sign, not a minus sign, a negative sign. For safety, I'm going to say 1, and I'm going to put this in parentheses. 1 divided by 3 makes your fraction. X, remember your X is right here next to the green alpha button, plus 74. So what we're going to do is we're just going to look at a couple of points on this graph, this line, to see if they could possibly be the line of best fit. So I have two x values that I'm going to be interested in here. I'm going to look at an x value on the left-hand side of my graph, and I'm going to look at an x value on the right-hand side of my graph. So I want to know when x is 15 and when x is 60. Okay, so we could do it a couple ways. We could go look in the table of values. Here, x is 60, y would be 54. So if x is 60, y is 50. Oh, that's like right there where that dot is, right there. You see that? So now I want to know where x is 15. So I'm just, because you only need 2 points to make a line. So I'm going to scroll back up here to where x is 15. And it says my y value there is 69. So I'm going to go to 69. Look at that. That's pretty close. So if I take my handy dandy ruler and I connect these two lines, well, that looks like it's going pretty well through the middle of the data. My guess is that's going to be our line of best fit. This is my B line. A had the wrong slope, so we didn't even draw it. So let's take a look at the other equation. So right now we think it's B. But always double check, always. So I'm going to go back in and I'm going to put the C equation in. So that's negative 2/3 plus 80. Okay, go look at your table of values. If my x is 15, it says my y is 70. So if my x is 15, my y is 70. Well, that's okay. I don't mind that. That's right there where the other one was. But let's go look on the other end of the graph so I know where I want to connect it to. And let's just go where my x value is 60. So I'm just going to scroll real fast. It'd be at 40. Your y value there is 40. Well, 40 is way down here somewhere. We don't even have, our graph jumps from 0 to 56. So 40 would be way down here. So my line would do something like that. So that clearly is not going through the middle of the data. So it can't be C. And then let's look at D. Go back into y equals, and we're going to just change the equation to match what's there. It's negative 1/3 plus 50. Hopefully you're noticing that y-intercept is awful low. 50. This is the y-intercept right there. Let's take a look at the right-hand side. If my x value is 60, my y value is 30. So 60 and 30 is somewhere over here. All right. And then if we're going to look at the left-hand side, we're going to go back to where x is 15. and my y value there is 45. That's not even on the graph. It's down here somewhere. So that can't possibly go through the middle of the data. So B is going to be our line of best fit. So you're really just looking what works the best. This one we might have been able to estimate pretty well based off of the y-intercept, but they don't always show you the y-intercept. So that's why I was showing you on the calculator. Let's see here. So here, my origin is really right here. There's my y-axis. There's my x-axis. So you're just seeing this like scaled out view. All right. So let's take a look. We're going to do the same thing. We're just going to use our calculator, and I'm going to pick an x value on the left-hand side and an x value on the right-hand side to kind of see how these lines are going to fit for me. So let's look at the A. So you're going to go into y equals, and we're going to say x plus 1.3. And look at our table of values. We want to start at -5 now. So we're just going to go up to -5. When x is -5, y is -3.7. So I'm going to go where x is -5 and y is -3.7. So like right there. That feels pretty good because it's in this data. Let's see what happens on the other end of this so we can connect our line. We only go up to +5 here. So I'm going to look where x is +5. And that says I need to go up to 6.3. So 5, it's a little bit off, so I got to estimate where 6.3 is. But look at that. That looks pretty good. If I connect those 2 points together, that feels pretty good, like it's starting to estimate the center. So I'm going to label that. That's my A line. I feel pretty good about that. But always check. My B line is negative. The slope of this scatter plot is positive, so it cannot possibly be B. C is 2x plus 1. So we can just check it real quick. Go into y equals. I'm going to clear that out and say 2x plus 1. And look at my table of values. When x is -5, y is -9. So that's down here somewhere. Because here's -5, -6, 7, 8, 9. And if x is +5, we'll go look at the other side. I don't think we can possibly save this. It's 11, which is way up here somewhere. So it's going to be this more cross like that. So that doesn't approximate the center of the data. So that's not going to work for us. And then our last one, we'll just check it because I think A is the winner. Clear this out. Whenever there's a fraction up front, I like to put it in parentheses. 1/2 x plus 2. Look at your table of values. On the +5 side, it'd be 4.5. +5, 4.5. Well, that might work. We'll see what happens. Okay, and then on the -5 side, go to where x is -5. I need negative. Oh, look, -1/2 is right there. So this is way too flat. I needed to go a little bit steeper. So A is definitely our answer there. Of those choices, that one's the best one. All right. So let's take a look at this next example, and then we'll do an application problem so you can kind of see how this all starts to go together. This is a dot plot. As x gets bigger, the y's are get smaller. It's a negative slope. So I always check for that first. D has a positive slope, so it can't be D. It's just not possible. All right. And so let's see, we've got our y-axis is right about here. And our x-axis, we can't even see. It's up here somewhere. Okay, so we're just going to kind of look at this. So clear this out, and I have negative 2x minus 1. Go look at your table of values. If x is negative 5, y is positive 9. I don't even know where that is. That's like way up here, positive 9. And if I look at the other end, I get x is negative 11. So it's going to be this line that comes like this. That's my A line. That doesn't feel good at all. As straight as this is and as close as these are grouped together, I should have a line that goes like right in there. So let's see what happens. Let's try the B one now. Clear out what you've got. You got negative 1 divided by 2, x plus 2. Look at my table of values. If x is 5, y is negative 1/2. So if x is 5, y is negative 1/2. Oh, that's not feeling good at all. Look where that is. That's not even in the same ballpark. And it's actually up here. Okay, so this isn't feeling very good. Let's see what happens. Let's go look on the other side, because I did when x was a positive 5. Let's look where x is a negative 5. And I got positive 4.5. Well, this is negative 1. So positive 4.5 is up. This line is nowhere near our data, so it can't be B. Which tells you it should be C, but we're just going to verify. Y equals negative 1/3 minus 3. Okay, look at your table of values. Negative 5 and negative 1.3. So where x is negative 5, y is negative 1. Oh, that feels good. Look at that. I like that. Let's see what happens on this other end, where x is positive 5. I got negative 4.6. There's my x is positive 5, negative 4.6. That's it. Look how we got dots on both ends, and we can connect them. It's not perfect, but of the ones there, this is by far the best one. So we're going to call that our line of best fit. All right, let's put this all together and see what happens. Okay, so take a second. These are points. These are coordinate points. Go graph these and then come back. Stop your video and come on back. All right, so here I have a table of values that represents the amount of time students studied for a test and their test scores. So an amount of time spent studying and their test scores. So we can look at this. We can see it's a positive relationship. The more they studied, the higher their test score. Okay. Does it look linear? I think overall we're going to say that it's linear. So let's just say yes here. Unless it's something obviously curved. If these guys had been down here, we would send up and down, then I would have said, no, it doesn't look linear at all. Does this have a positive or a negative relationship? It has a positive relationship. Now, let's get the correlation coefficient. We've done this a bit. I'm going to show you in the graphing calculator. Stat, edit. Your instructions are right here. You can use the Desmos, or this is a simpler graphing one, a simpler one. You can scan it with your phone. So you have 3 different ways you can approach this right now. Okay, to get this, we need to put in our data. So clear out your lists. My x values, 3, enter. So take a second and put your x and y values in and stop your video and come on back when you're done. All right, so now we have our data in list 1 and list 2. X's are in list 1, Y's are in list 2, and you made sure you went in the same order for both lists. To get to correlation, you're going to press the stat button, arrow right 1 time over to calc. You're going to come down to number 4. You can just press 4 to get there. LinReg AX plus B. We put our information in list 1 and list 2. Okay, and our correlation coefficient right there, 0.8547, and then the next one is 8, so I'm going to round up that 7 to an 8. So my correlation is 0.8548. That's my correlation. So let's talk about this. We're going to interpret it, form, strength, and direction. There doesn't appear to be any outliers. If there's something way outside a pattern, we would mention that too. The form, we're going to say linear. It's not obviously curved. 0.85 is strong, and it's a positive number, so we'll say positive. Now, we don't even have to do anything extra. We can write the equation of the line of best fit. See right there where it says y equals ax plus b. That's your equation, mx plus b, slope, and that's our y-intercept. And then there's an a and a b right below it. You're going to take the numbers. Where a is, you're going to plug in 6.27. Where b is, you're going to plug in 49.8 because we're going to do some rounding. So here's what I mean. We already have the y equals. A is 6.27. And then we have an x. And then our b value is a positive number, so we'll say plus 49.8. That's our line of best fit. You don't have to calculate it by hand. Your calculator will do it all for you. We could go check it, and it would do the best to approximate the center of this data. Now, the whole purpose of this is we can make a prediction using the line of best fit, predict the test scores with somebody with 1.5 hours of studying. So hours of studying is an x value. That means where x is, you want to plug in 1.5. So we're going to say y equals 6.27, and the x I'm interested in is 1.5 plus 49.8. From there, you can just put that straight into the calculator. 6.27 parenthesis, 1.5, close your parenthesis, plus 49.8 is a 59.02. So we would estimate their test score to be a 59. All right, let's try it again. And then you have one to work on your own on Canvas. So carbon dioxide is a greenhouse gas that is emitted into the atmosphere from a variety of artificial and natural sources, including automobiles. The table below shows the concentration of carbon dioxide, which is CO2, in the atmosphere measured in parts per million. When entering your data, use x equals 0 to represent 1970. So sometimes we see this a lot. So instead of having us put in the years as the whole year, they'll tell you to start, this year is 0. 1976 is 6 years after that, so 1976 will be an x value of 6. 78 is 8 years after that, so that's 8. 80, 10. 82 is 12. 14, 16 years after, 18 years after, 20 years after, 22 years after, 24 years after, and 26 years after. What I want you to do is these are your x values. These are your y values. Let's go put them in your calculator and come back once you're done. Okay, so I've got my x values in my list 1, my y values in list 2, and we're going to find the equation of the line of best fit. Stat, arrow 1 right to calc, choose number 4. Our x's are in list 1, y's are in list 2, enter, enter, enter. And I'm going to plug in a and b. So we get y equals 1.49x plus 323. We'll go ahead and leave that one a whole number. Okay, and that's just coming from right here. The next question is, what is the correlation coefficient? Remember, that's R. So I got 0.9985. Okay. Interpret this. That's a very strong, so we'll say strong as a positive number. And we'll say it's linear unless you know otherwise. Okay, so now using the line of best fit, estimate the number of parts per million in the atmosphere in 2000. So that's our x value. But remember, it's years since 1970, so we want to subtract 1970 to get 30. 30 is what we're going to plug in. If we kept this table going, 2000 would have been represented by the number 30. And years are x values, so we're going to plug it in. Y equals 1.49, and we're talking about in 30 years, plus 323. All right. When you work it all out, you can just put this straight into the calculator. I got y equals 367.7, and there are units, so go ahead and use them, parts per million. So you can just use the line to make an estimate of what you think the results might be in the future. All right. Hopefully that's not too confusing. I'll do a separate calculator and Desmos video in case you need to view it again. Thanks. Let me know if you have any questions.